Hello everyone, my name is Robin Kepps, and on behalf of the other authors, I'm going to present you our work on weakly supervised color array GAN for controllable makeup transfer. In this paper, we address the task of makeup transfer. This task consists of training a model to extract the makeup from a reference portrait image and apply it to the target image of a different person. However, existing makeup transfer methods suffer from a lack of control, as the generated makeup image cannot be edited to explore other looks. There has been recent interest in the community to create makeup transfer methods that are controllable. However, they only achieve control in terms of makeup transfer intensity and do not allow to simulate another closed makeup shade or a target cosmetic product. We propose a new formulation for the makeup transfer problem, where the objective is to learn a color-controllable makeup synthesis. In this objective, the color of the transferred makeup is explicitly represented and can be controlled manually by the user in order to explore the space of possible makeup colors. Our contributions can be summarized as follows. First, we introduce CA-GAN, a model that learns to modify the color of specific objects in the image to an arbitrary target color. Second, in order to remove the need for costly color labels, we introduce weakly supervised learning for GAN-based controllable synthesis. Furthermore, we share a new dataset of makeup images with increased variability in skin tones, facial poses, and makeup color. Finally, for the first time, we introduce a quantitative analysis of makeup style transfer performance using ground truth image triplets. While some existing GAN models attempt to modify color attributes in an image, they only provide control on discrete color categories. For instance, the StarGAN model learned to modify the color of hair to the blonde category, but cannot control the exact color or model several blonde color variations. Our proposed CA-GAN architecture takes as input a source image together with a target color value represented as a triplet, and generates an image where the attribute of interest has been modified to reach a target color. However, training such a model requires color labeled data, which is rare in practice. In order to relax the need for labeled data, we propose to use weakly supervised learning. An example of this approach consists of using an unsupervised model on unlabeled images to produce weak features. These features are then used as labels for training a model in a supervised fashion. Even though these features are noisy, they provide a supervision signal that, when leveraging large amounts of unlabeled data, allows to learn a strong predictive model. In the case of makeup, we extract weak color information by building on the assumption that makeup is localized in specific region of the face, which can be approximately estimated using standard face processing methods. We then compute the median pixel color in this region to estimate weak color features for makeup and skin color that will be used as labels during training. As illustrated in these examples, our weak color feature extractor is noisy and might fail in case of complex poses or occlusion by hair or eyelashes. However, its role is only to provide supervision signal to discriminate so that it can learn the representation of makeup color. Because of GAN's limitation to generate high-resolution images from small amount of training data, most existing makeup transfer methods use portrait images in low resolution, such as 256. Instead, we choose to train our model on local crops of eyes and lips. In this way, we can process eyes and lips in their original size and output a generated image with unchanged resolution. We can now describe the training procedure of our CA-GAN model. We first compute color features using our weak model. Then, the generator estimates an image from a source image and a target makeup color. Second, the discriminator estimates the makeup color in the generated images, which allows to compute a color regression loss. In addition, we use a GAN loss that enforces the realism of the generated images. This helps the generator to learn which pixels should be modified in the source image in order to realistically change the color of the object. However, since we are training on crop images, we need to ensure that the background skin color stays consistent with the portrait image. Such changes might not be penalized by the discriminants since they can remain realistic at the crop level. Thus, we introduce a background consistency loss by training the discriminant to estimate skin color in the generated image. Finally, as we are training on unpaired images, we use a cycle consistency loss that ensure that the source image attributes remain perceptually unchanged. As illustrated in these examples, the CA-GAN model learns to realistically change the color of the makeup in eyes and lips images. Notice that even though there is no special information passed to the generator, our weakly supervised approach is capable to learn an accurate segmentation of the object of interest. In addition, since color is represented in a three-dimensional space, our model can modify color in a continuous manner to reach any shade variation. To perform makeup transfer, we use the discriminant module to estimate makeup color from the reference image. The estimated color is then passed to the generator together with the source image to produce the estimated makeup transfer. Here are video examples of our makeup style transfer for lips. The synthesized images are realistic, and the makeup appearance is successfully extracted from the reference image. You can see other style transfer results on eyes makeup. Notice that even though our model was trained on images only, there are very few flickering artifacts in the generated videos. Compared to other makeup transfer methods, our model shows qualitatively superior results. In particular, it is able to better preserve the skin color and the background from the initial image, which is key in virtual try-on applications. Finally, for the first time, we propose to quantitatively evaluate the realism of makeup transfer. This is done by collecting triplets of aligned images with various makeup shades. Reference makeup is extracted from person A and applied to person B. Since we have access to the ground truth of person B with the same makeup, we can directly compute a perceptual distance. These results confirm the superiority of our method. In conclusion, we have presented an architecture to learn color controllable synthesis using only weak supervision. We have successfully used this model to perform makeup transfer on portrait images. Furthermore, we can stress that our model can be used for all image categories for which pixel location can be estimated. Thus, it could be directly adapted to learn color control of various objects, such as hair in portrait images, car in driving datasets, or garments in fashion images. For more information and examples, feel free to visit our project page. Thank you for your attention.